Okay, you're going to think that this warm-up is really weird, but I want you to just humor me. Find the ratio. So what does ratio mean?
Fraction.
Divide, fraction, very good. Find the ratio of the height to the base and round to the nearest thousandth for each triangle. So I want everyone to write it down. 1, 2, 3. 5 divided by 10.72. And you write down to the nearest thousandth. 80 divided by 171.56. And you write it down to the nearest thousandth. 11 divided by 23.59, nearest thousandth. Okay, so what did y'all get for that first triangle? What's 5 divided by 10.72? Thank you. Is it 0.466?
Yeah.
Oh, it's doing the weird thing where it slashes through my numbers. Sorry. Okay, what is 80 divided by 171.56? You're typing it in the chat. Good job. 0.466. Good. And what's 11 divided by 23.59? Why is this, guys? Why are we getting the same number each time, even though if these were drawn to scale, these would be totally different looking triangles. Like this is 80 units long and this is 5 units long. How come we're getting the same number every time, even though these triangles are hugely different sizes? Love it. You notice that they all had something in common. They're all right triangles. They're all right. And they all have an angle of 25 degrees. Do you know what these triangles are called? They're not congruent, but they are... Yay! These are similar triangles. And what we're going to learn today, trigonometry, relies on similar triangles. There would be no trig without similar triangles. So trigonometry is going to use the fact that, whoa, the opposite over the adjacent ends up being the same decimal every time. Every time the angle is 25 degrees. This divided by this gets the same exact number. Trig is going to use that pattern to help us solve for lots and lots and lots of cool things. All right, so like I said, get out your notes and let's introduce the lesson. Let's look at these 4 different situations. Do not write this down in your notes. Let's brainstorm what our strategy would be to solve for each one. Number 1, yell it out. How do you solve for x? What's the most efficient way?
Pythagorean theorem.
Pythagorean theorem. Thank you. 5 squared plus 3 squared, and you square root it. All right, number 2, what's the most efficient way to find y?
45, 45, 90.
Thank you. That's a special right triangle. Oh, no, it's doing the thing. Okay, there. 45, 45, 90. Very good. Number 3.
30, 60, 90.
It's special. We just took a test over this. Very good. 30, 60, 90. And finally, number 4. How do you solve for x? Trick question, Miss Tanton. We can't, right? So we know how to solve for a lot of right triangles. But guys, we can't find that distance. I can't find the distance from A to B, and that's not okay. I can't graduate geometry not knowing how to find that side length. I want to know how to find every side length of any right triangle I'm given. So that degree is 20. 20 is not special. It's not a special right triangle, and I can't use Pythagorean theorem with a side and an angle. That's why we have what? Trigonometry. Yes, trigonometric ratios. That's what trigonometry is for. Why do we need trig? Because of problem number 4. Because until today, we could not solve it. And we need a strategy to solve for it. All right, so why do we have trig? What is trig, that fancy word, and who uses trig? So trig was not created because someone was just studying math all day. They just loved math. I'm sorry, that's not how trig came about. Trig came about as the byproduct of people studying astronomy because they thought that was way more cool and interesting than math. So the Greeks over 2,000 years ago, they were studying astronomy, the sun, the moon, how do planets orbit, how far away are they from each other, what's the angle from this planet to this planet. They were curious about the planets. And through their curiosity, that's how trigonometry was born. Because what trigonometry does is it takes one angle and one side length. Like let's say you knew the equator of the earth, or you knew the diameter of the earth. You use one angle, you use one side length, and boom, you can find the distance from the earth to the sun. You can calculate the distance from Jupiter to Mars. You can find the distance from the moon to the earth. You can find distances that are unmeasurable knowing one angle and one side. And so that's how trigonometry was born. It was born because people were studying the stars. Now, not just astronomers use trigonometry. Oh my goodness, so many people use trigonometry. Not just math majors. When are we going to use this, Miss Stanton? So, who is musically talented? Who's musically talented? Yes! Composers, and did you know there's such thing as a sound engineer? I bet you did if you're musically talented. They use trigonometry because sine and cosine, that's trig, those are waves, sine wave and a cosine wave, and sound waves sound travels in a wave, and sine and cosine are waves as well. So they use trigonometry to model and represent the sound travel. So the really, really deep composers and sound engineers would use trig. Cartographers, map makers, they don't use regular trig. They use spherical trig to find out distances from cities and to make maps of the earth. So if you wanted to know the distance from Madrid to Houston, that's not a straight line. So they use something called spherical trigonometry, where they are using the curve of the earth and finding distances that no one wants to measure by hand. That's what trig can do for us. There's a picture of the space station. It might be an old picture now. It might look a lot different now. But that is an astronaut on the arm of the space station. And one of our teachers here at Cy Falls, her husband worked for NASA and said he really used trig when he worked on this arm of this space station. Like he drove to work, sat down, and used trigonometry to calculate how big the pieces should be, the angle of the arm, the distance, the length. Pretty cool. The last one that's kind of trendy right now on TV shows is, forensic science, who did it, crime scenes, blood splatter. Well, that blood splatter came from a trajectory. It came from a length of a triangle. You can turn it into a triangle. So finding the angles of the splatter and the distance, where was the person standing, what angle did the weapon enter, all of that you can use trig to model. So anyways, I spent a long time. I hope I convinced you that a lot of people use trig, not just stuffy math majors like Miss Tanton. Okay? Okay. Go ahead and erase your annotations. Write this down. A trig ratio is nothing fancy. I feel like everyone thinks a trig ratio is some magical, mysterious thing that happens in your calculator, but it's not. Trig is just the ratio of two sides of a right triangle. Trig is what we did in the warm-up, and I'll show you how in a minute. Trig is just a ratio. It's a ratio of two sides, and it has to be of a right triangle. So when I say tangent and sine and cosine, think, oh, we're just dividing sides of triangles and using the fact that similar triangles have the same side ratios. You don't need to write this down in your notes. This part right here you don't need to write down. The three most common trig functions are sine, cosine, and tangent. Sine, cosine, and tangent. Trig means, like if you're just wondering, I'm not going to ever ask you this on a test, but trigonometry, trigonom and then metron, it means triangle measure. So trigonometry is a fancy way of saying, hey, we're finding measures of sides of triangles. All right. Find these buttons on your graphing calculator. Locate them. Sine, cosine, tan. These are those 3 trig functions we were talking about, and these are the buttons you're going to be using. Now, very, very, very of utmost importance. Your calculator has 2 modes when it comes to trigonometry. It has 2 modes. It's got a radian mode and a degree mode. And the bad news about that is that radian mode is the default, and we're not studying radians, and we're not doing trig in radians. We're doing trig in degrees, like 25 degrees, 72 degrees. We've learned about angles in degrees, not in radians. So every time you clear your calculator, and some of y'all are like compulsive clearers, like, oh my gosh, every time you solve something, you do second plus 7, 1, 2. I wouldn't do that anymore. Every time you clear your calculator, you're going to need to press mode. Everyone press mode. You're going to need to press mode, and then you're going to need to highlight degree and press enter. The degree one needs to be highlighted. The degree needs to be dark. Radian cannot be dark. We're good on that? I'll show you on my little calculator emulator. We press mode. See over, oh, I'm in radian mode. Shame on me. So I go down to degree. It's blinking. I press enter, and now I'm in degree mode. And now I can quit out of there, and I can start solving problems, okay? So we want to make sure we're always in degree mode. Okay, we're going to be doing a few things, and none of it's going to make sense until the very end of class. So I'm going to be laying the groundwork, and you're not going to be able to see the house. You're only going to see the little skeleton and pieces of the house until the very end, so just trust me. Let me introduce you to Bob. Everyone say hi, Bob. Hi, Bob.
Hi, Bob.
Bob is standing at angle C. That is his perspective, okay? So compared to Bob, which side is the opposite leg compared to angle C?
AB.
Thank you. Good job. AB is the opposite leg. I have to get my select. Okay. So AB compared to Bob is opposite. What's the hypotenuse of the triangle? Hypotenuse?
AC.
AC, thank you. And so which side is adjacent to Bob, of course?
BC.
BC, the only one left. Now, what does adjacent mean? Adjacent.
Next to.
Good, that's exactly what I wanted you to say. Adjacent means next to. Now, I agree, there's 2 sides next to Bob. There's BC and there's AC, right? But AC is the hypotenuse, and hypotenuse trumps adjacent every time. Hypotenuse trumps adjacent. So never call the hypotenuse the adjacent side. Don't ever do that, okay? So what happens, though, is if I put Bob at another angle, by the way, Bob never goes at angle B. We never do trig from the right angle. It doesn't even make sense. You'll get an error in your calculator. You never do trig from the right angle, always one of the acute angles. So if Bob was at A, everything would change. Which side would be opposite?
BC.
Yeah, adjacent and hypotenuse. All right. It does make no sense. Thank you. Good. I promise it'll make sense later. Okay, so now that we've used those words, adjacent and opposite, now that we've used those words, I'm going back to the warm-up. This is what we did at the beginning of class. Notice, compared to the 25 is where Bob is. Bob's hanging out at 25. Compared to 25, what we did in the warm-up was we divided the opposite by the adjacent. Opposite divided by adjacent. Over here, opposite divided by adjacent. Opposite divided by adjacent. Now, what did we get all 3 times? What was that decimal?
0.46.
Yes. Every time we got 0.466. And we noticed that what these triangles had in common was the angle. 25, 25, 25. Now I want everyone to go to their calculator and type tangent 25. Type tangent, the angle they had in common, tangent 25. What do you get to the nearest hundredth? Whoa! So you were really, these are equal. You were really doing trig in the warm-up. Trig, tangent, is just a ratio. It's just a division problem. The tangent of 25 is every right triangle with a 25-degree angle. It's dividing the opposite by the adjacent every time. The tangent of 25 is a constant. It's a number, and it never changes. Okay, so we're going to be using the fact that every time you take the tangent of 25, it's the same number. That's what we're going to use to help us find missing sides of triangles that we couldn't solve earlier. Okay, write this down, only this part of your notes. Write it down. We're going to learn the sine and the cosine ratio tomorrow. So just today, write down the tangent ratio is opposite over adjacent. That's why we did Bob. We wanted to make sure we knew which side was opposite and which side was adjacent. So compared to angle A, I've labeled the triangle opposite, adjacent, and hypotenuse. But all you're writing down, tangent equals opposite over adjacent. And you might be thinking, what about the hypotenuse? Are we never going to find the hypotenuse? We will. We'll be using the hypotenuse tomorrow with sine and cosine. But today, tangent only needs the opposite and the adjacent. All right. I know it still doesn't make sense. Don't you worry, I know. These next 2 pages, we are not going to solve for a thing. We are not going to solve any problems, but we are going to practice the ratio. So what's the tangent of angle A? Opposite divided by adjacent. What's the tangent of angle A? Go.
Opposite over adjacent.
Yes, what does it equal? What does it equal?
3/4.
Good. 3/4. Oh, sorry, Smart Notebook is doing weird thing. That says a 3 1/4. The tangent of A is, okay, well, what's opposite? 3. What's adjacent? 4. So 3 over 4. It's a fraction. The tangent of A is prettier than 0.466. It's 3/4. It's 0.75. Okay, now Bob is standing somewhere else. We moved locations. Now we're here. This is where we are. What's the tangent of B?
4/3.
Whoa. Trying to make it not do that. What are these 2 fractions called, guys? What's the fancy word?
Reciprocal.
Yes! These are reciprocals, and that's not a coincidence. That'll happen every time. The tangent of one angle and the tangent of the other angle will always be reciprocals. Okay, let's try one more. Remember, we're not solving anything. We're not finding a missing side. We're just practicing the ratio. What's the tangent of angle S? S is an angle, by the way, not just a capital letter. Yep. So what'd y'all get? What is the tan of S? What is opposite over adjacent for S?
15/8.
Thank you. I'm so glad you said that. Remember, another question that I answer the same thing to every single time is, Ms. Tan, do we need to simplify our answer? You don't need to ask me that. Always simplify your answer. Always simplify your answer. Always simplify your answer.
Does that say 18?
No, it doesn't, guys. Smart Notebook is adding extra slashes, and I cannot control it, okay? So you know what 30 over 16 reduces to, okay? So it's 30 over 16. That's step 1. You always reduce / simplify your answer every time, no questions asked. What's the tangent of angle T? Yeah, it's just the reciprocal. It's just the reciprocal. Yay, it didn't do it. See how weird I had to write my 5 for it to not do the slash?
That's a rule, right?
What?
That's a rule.
A rule that they're going to be reciprocals? Yeah. Not a coincidence. Good. Write this down in your notes. Trigonometry anatomy. Doesn't that sound fun? Hey, daughter, what'd you learn at school tonight? Well, we discussed trigonometry anatomy. Sounds so clever. Write it down. This is what a trig equation looks like. And this is what all of ours are going to be set up like every time. So we get to follow the same pattern. First, you write the trig function. Today, tangent is the star. We'll do sine and cosine tomorrow. So first, you write the trig function. Then, in parentheses, you write the angle measure. Only the angle measure. The only thing ever allowed in parentheses is the angle measure. Then you write the ratio. And remember, for tangent, the ratio is opposite over adjacent. But that's going to change for different triangles, so I want you to just call it a ratio. Don't call it opposite over adjacent. So if you notice, this equation came from this triangle. Tangent of, what's the angle? What's the angle? Oh, 31 equals, and then they wrote opposite over adjacent, opposite over adjacent. And now we have an actual equation that has an actual variable and will actually solve and will finally find things. We haven't found anything yet today. We haven't solved any problems yet. Can I move on? I'm going to go with yes. Okay. Please write this down as well. You are getting your note writing in today. There are 3 scenarios that you can encounter. And in each scenario, x is in a different location. Scenario 1, x is in the numerator. Scenario 2, x is in the denominator. Scenario 3, x is trapped in the trig function. So we're going to find out what do we do each time, depending on where x is. So to find out what we do each time, we are going to solve the equation like we would solve any equation. First, I'm going to put tangent of 23 over 1, and then what am I going to do? You guys know it. How do you solve fraction equals fraction? I was thinking of something different. It starts with a C. No? There we go. 3rd time's a charm. I was thinking cross multiply. Sorry, I make y'all read my mind sometimes. So 19 times tan 23 equals, oh, x times 1. Cool. X. Guess what we get to do from here? We get to go to our fancy schmancy calculator. Everyone type it in. 19 times tan 23. Enter. We have now solved for x. Let's round to 2 decimal places. What'd you get? Okay.
8.07.
Good. It's 8.07. The 5 tells the 6 to bump up. We found a missing value. Yay. We cross-multiplied, and we found a missing value. Okay, scenario 2. X is in a different spot now. Cross-multiplying is going to look a little different. 19 times 1 is 19. X times tan 23. We need to solve for x. How do we get x all alone? How do you want to solve?
Divide by
Yes. Oh, I love it. I love it. Good. Get rid of that tan 23. Whatever you do to one side, you must do to the other. Whoosh. So in your calculator, type 19 divided by tan 23. 19 divided by tan 23, and that is a 3 doing a weird thing again. What do y'all get?
11.96.
44.76. Did you make sure to put the 19 first? 19 divided by tan 23. Check your buttons you pressed. Make sure you're in degree mode. Okay, so let's summarize. Let's summarize what we did so far. On this one, x was in the numerator, and we multiplied. Numerator, scenario 1, multiply. Where was x in scenario 2? Where?
Denominator.
Denominator. I love that. Because that's an alliteration. Denominator, divide. Sorry, that's an I. When x is in the denominator, we divide. Denominator, divide. Denominator, divide. And last place tangent can be. The last place it can be is trapped in the tangent function. When x is trapped in tangent, we have to do the opposite of what's being done to it. We have to do the opposite of tangent. What in the world is the opposite of tangent?
Adjacent. divided by opposite.
Ooh, that's a good idea. But I'm going to show you on your calculator. Oh, I can't write on this. Everyone look above the tangent button. Above the tangent button. The opposite of tangent is something called inverse tangent. How do you get to it on your calculator? Second. Very good. So second tan, that right there is the inverse of tangent. It's not really the reciprocal. You'll get into that in pre-cal. But it's the inverse. It's the opposite of tangent. So the way to undo tangent is to inverse tan. So I'm going to do tan to the negative 1. I'm going to press second tan. And then I'm just going to put my fraction in just like they gave it to me. So how do you undo this? Second tan. Go ahead and find out what it equals. This time, we're going to round to a whole number because this is an angle, and we're going to get used to rounding angles to whole numbers. What do you get? What's the missing angle? 25?
26.
26 degree angle. Okay, 26 degree angle.
Oh, right. Sorry.
Yeah, round to the whole number in this one. Okay, so those are the 3 places x could be. Let's try them a little. What? Let's try them. Let's just try some. All right. What do you do here? What do you type in your calculator? Where is x? Denominator divide. Now be careful. It does matter which one you put first. You must put the number, the side first. You must do 27 divided by tan 62, not the other way around. Every time you put the number first. Denominator divide. 27 divided by tan 62, 14.36. Okay, what about this one? What do you do? How do you solve?
Multiply.
No.
Inverse.
Inverse tan. Very good. You press second tan, and then you type 26 over 12. I don't even care that that's not reduced. I don't care. The calculator will do it. Second tan. 65 degree angle. Awesome. All right. What about this one?
Numerator multiply.
Numerator multiply. 35 times tan 54. Oh no, it's not an 8, it's a 5. 48.17. All right, last one. What do we do here? Inverse tangent. Very good. Second tan. Ooh, it's not a fraction. Is that okay?
Yes.
You just put it in the parentheses. It is okay.
20.
What?
20.
20 degree angle? Yep, 20 degree angle. Good. Okay, so we finally made it to the end of our lesson where we're actually finding missing sides of triangles. All that we did up until now was to get us ready for this moment. Okay, so now you're going to be given a triangle like this. You don't know the missing side. You need to find this length. And Pythagorean theorem isn't going to cut it. It's not 45, 45, 90, and it's not 30, 60, 90. So you say, hey, I have to use trig. Here's what you do first. You write an equation. Don't you dare do trig without writing an equation first. I write what's called the skeleton first. I write an empty trig equation just so I know I have all the pieces. Then I plug stuff in. What goes in the parentheses?
22.
The angle. Only the angle, always the angle, every time the angle. Very good. 43. And what do I put in my fraction?
X over 12.
Good. Opposite over adjacent. Opposite over adjacent because that's the tan function. Now, can you solve it? Can you find how long that side is? Multiply or divide? What do we do?
Multiply.
Good. 12 times tan 43.
11.19.
Perfect. Let's try another one. Okay, so we write our template. We know it's tangent because we're only studying tangent today. Okay, class, what goes in parentheses? Anybody who has the mic?
23.
There you go. Keep going. You keep annotating. I love it. Equals?
18 over x.
Yes, you can annotate that. I'll let you do that. Hey, class, where is the variable? Where is the variable?
Denominator.
Denominator divide. Denominator divide. You better put that 18 first. Never put, oh, don't erase it. Your annotation. Better put the 18 first. 18 divided by tan 23. That is a really long side. What is it?
42, 41.
Good. 42.41 units long. A very long side. All right. Let's do one more and then we're done. Go ahead and erase your annotations. Erase. Come on, magic, erase. Okay. What do I put in parentheses this time? Good. You put the angle no matter what the angle is, even if the angle's missing. Good. You put the angle in parentheses equals opposite over adjacent. Remember, always opposite over adjacent. All right, good. You can keep annotating. Inverse tan, second tan, 17 divided by 26. It says round to the nearest degree. What's the measure of the angle?
33.
33-degree angle. There we go. Your threes are better than mine because it doesn't auto-correct you. All right, that was a very long lesson. Our lesson is over.